Video, we're going to devote some time to thinking about functions and how they work in R. Now, I'm not going to have you write many of your own functions, especially early on in the course. We're going to use functions that have been created by other people to do specific tasks, but it is important that you know how functions work and what kind of arguments you need to put in them, so on and so forth. It's going to make your life a lot easier if you understand functions. And so that's why I'm going to talk about them here. I'll show you how to create your own functions. You don't need to worry about that right now. That's only going to happen a little later. But so this is what we're going to go over. We're going to talk about function components. This is some really sort of low level R stuff that you're never going to see again, but I do want to show it to you for completeness sake. The function components, the body, the formals, and the environment, the arguments, and then an introduction to scoping. We're going to spend most of our time on the arguments and how the arguments work, because that's what you're going to have to interact with the most. Now, I have this slide. This was at the beginning of the data science slide, and I put this here again just to familiarize ourselves with R. I don't really care about the top part, only about the bottom. R's basics rules are that everything that exists is an object, and everything that happens is a function call. Now, there's going to be a lot happening, and so there's going to be a lot of function calls. So, what is a function? Well, you can think of it as the same way as in a math course. If you are a math major or have taken math classes lately, you've probably used a function, especially in calculus, pre-calculus, and really everywhere. You put something into a function, and then it spits something out. It is a machine of sorts. Here specifically, it's an operator that takes in some objects, multiple, possibly, probably, and then returns an object. So it is an operator, and you'll hear me use the term operator a bunch. I don't know, you can think of it as a black box, a machine, something. So even something as simple as 2 plus 2, which is probably the first thing I showed you when I opened up R. It's what most people learn first about R, is that it's a calculator. But 2 plus 2, there involves a function call here, and the function is the plus, okay? And then we have something maybe more similar, this sum of a vector, 1, 2, 3, 4, 5, that's a function call. And then here is another way that you might see a function. Here I'm defining my own function. So the plus is certainly defined as an operator in R, so is sum, those would make sense. And then down here, I'm defining my own argument, which is my own black box, where I input x, whatever x is, and it will output x cubed. Okay, and so if I evaluate f of 4, I'd get 12. Okay, so defining a function looks like this. Okay, there are 3 parts of a function. So every function, where I say almost every function, has these 3 parts: formals, body, and environment. Again, this is not going to be essential for you to understand everything that we do, but it's going to help. So RC's, so formals, body, environment. Actually, it'll probably be helpful here for you to follow along and do the same thing I do. That's going to be a little bit different for me, but you can follow along by putting your function here, running it. So I have a function now, f, and I can evaluate it. So f of 4, 64, 4 cubed, okay? As I said, if we look for formals, if we look at the formals of f, you see it's just x. So formals are roughly the arguments of the function. Okay, and then there's the body of the function. So body of f. It's going to tell you what's inside. Again, we defined it, so it's not very exciting what that gives you. And then the third part, the environment, of f. Here it says something weird, our global environment. Now we're going to talk about environments briefly during this video because they are important to keep track of, and it can be very annoying, we'll say, annoying at the least, when you don't understand environments and they start messing with you. So anyway, formals, body, environment. Almost every function has them. There are a few functions that don't, and I'll show you that in just a second. Okay, and then here I said, how do you see a function? Sorry about that. How do you see a function? The str function. Okay, doesn't really give you much, but it's something. Or I'm sorry, yeah, str, and attributes gives you something. Now we don't have to worry about what all this is, and actually the str function is actually going to be more helpful for objects and not functions, but it does give you something here. Okay, but anyway, those are function basics. Okay, there are special ones that look like this. So if you look at the sum function, okay, it has no body, no formals, no environment. Those are primitives. They're so basic, they're so built into the R language that they don't have those basic things. Now, one small side note, how did I get the thing below sum? You'll see I have sum with no open and closed parentheses. In R, if you go to the command line and I type in the function name without the parentheses, okay, R is going to want to put them there. But if you take them away, it will show you the body. It'll show you the code of a function. Okay, so if I library the tidyverse, which we've worked with now for a little while, okay, and I look at the ggplot function, which you've had some experience with, hopefully, in the first week, you get this. Now, it's not very helpful. It doesn't say a lot. Just use method ggplot, whatever the heck that means, but it's there. So that's how I got there. Also, sorry for my dog if you can hear him whining in the background. Okay, so there's. Now, that's it for body, formals, environment. Okay, we'll come back to the environment. Now let's get to the arguments, or the formals. Okay, it's going to be the most important for you to understand. So when I have something like this up, the name of the function goes to the left of the parentheses, and the arguments of the function go inside the parentheses. It's very much a math. It lines up well with math notation for functions. F of x. The function is called f. It has arguments x. So R makes their functions, or R's functions function like math notation. Okay, so you have the function name to the left, arguments to the function. Now, there are two types of arguments, required and defaulted. Okay, well, they're maybe not all of them, but there might be one other category that I can't think of at the moment. So anyway, we won't get stuck on that. Required arguments need to be supplied at runtime for a function to run. So these are arguments that are not defaulted. Yeah, I'm sorry. It is required or defaulted. So they need to be specified at runtime. So meaning if you don't specify that argument in the function, it will error. So if you think back to my x cubed argument, or my x cubed function that I defined before, if I didn't put in a number. So if I didn't put in 4, it wouldn't give me out anything. It would error, and it would say argument X required. So that's a required argument, unless otherwise specified. So that's required. Unless otherwise specified, the defaulted arguments, will default to the values set in the function. Okay, what does that mean? So here's the ggplot example. Okay. You can't make a ggplot without data. I guess that is sort of not true, but for that's a niche case. Let's not worry about that too much. You're going to have to, unless you create your own, you're going to have to put in a data set. You might create a data set, but then you have to put it in to ggplot. The first argument to ggplot has to be the data, or data has to exist somewhere, and you need to let ggplot know that it exists. It won't create a plot without that argument. And so you see in the name of the call in the code that I have here, it just says data and nothing else. Okay? Whereas the mapping and the environment, they both have an equal sign next to them, and they say mapping equals something. Well, it's the AES function, the aesthetics function, which we know now. And then environment equals parent.frame. So it means that if you run ggplot with just the data and no aesthetics, nothing else, you just put the name of the data set, that function will run. It may not do what you want it to do, but it's going to execute. It's going to run. Okay, so required versus defaulted. So I have an example here. Okay, I want to simulate draws from a normal distribution. Now, this is a very statsy example. Okay, I want to generate 10 random numbers that happen to come from a normal distribution, that they're distributed in some way. Don't get too stuck on what I actually want to do. Okay, and so I do this. It's easily done with the rnorm function. We'll do a lot of stats, or we'll do some stats later on, probably in the 4th or 5th week of the course. But here I run rnorm 10, and I get 10 numbers, which is wonderful. Now, of course, I needed to tell rnorm how many numbers I wanted. That is a required argument, because it would be very odd if that function defaulted the number of things that it gave you. It's a pretty imperative part of the thing that you need to know how many you want to generate. Anyway, but is there anything weird? And of course, if you want to, you can pause the video and think about something that's weird, or we would have a class discussion. The thing that's weird is, what's the normal distribution that they actually sampled this from? So you have to think way back to stats. There's more than one normal distribution. There are infinitely many of them. And a normal distribution is defined by 2 numbers, the mean and the standard deviation. But I didn't give either the mean or the standard deviation. I just said I wanted 10 numbers. Okay? Is that weird? Kind of. Or I think so. And I think you should think so as well. Okay? That's because the mean and the standard deviation are defaulted. So they're defaulted to 0 and 1. Mean 0, standard deviation of 1. This makes sense. Maybe is a little bit reckless, but it makes sense because there's a special normal distribution that's used a lot in practice called the standard normal distribution, mean 0, standard deviation 1. So that's why it's defaulted. But of course, n is not, n is required. Those two are defaulted. Okay, so hopefully that makes sense. Okay, you need to give required arguments. You don't need to give defaulted arguments. You maybe should, depending on the problem. You may not get the correct result if you just leave the default arguments defaulted, but it will run at least. Okay, so the R documentation, for example, this, I took a screenshot of the bottom right of my RStudio at one time. it can help you. So the R documentation is pretty helpful when you're looking to see what arguments are required versus defaulted. So here's the normal distribution one that I would have used. Okay, and so if you look, you can see R norm at the bottom, N mean 0, standard deviation 1. So it gives you a description of the function with all of the arguments in it, both required and defaulted. Okay, now, how are they matched? Meaning, if I put in the arguments, I put in the name of the data set that I want into a ggplot call. Do I need to always say data equals something? Or what? Can I just put the numbers in? How do they match them to what? So, for example, I have a function here, it takes in 3 arguments, and I call the arguments location, scale, shape. They're stats words that we don't need to worry about at the moment. Okay? And all that this function does, it's a very simple function that just returns a vector with location, scale, and shape, the 3 arguments. But this is helpful in showing us how the arguments are matched. So down here, how is f of 1, 2, 3 going to behave? So we said 1, 2, 3. Do I mean location, scale, shape, so on and so forth? Okay. And so take a second, pause the video, guess what's going to be the outcome. Okay, so here's the outcome. It is 1, 2, 3. Okay. I don't think that should be very surprising to you. Of course, it's going to put, I gave 1 first, and so it's automatically going to match to location, 2 is to scale, 3 to shape. Okay. Now what if I get more exciting? Okay. Scale is 1, 3, and then 2. Pause the video and guess. Okay, here's the outcome. 3, 1, 2. Okay, so by default, we say not default, I provided scale. Okay, so I provided scale, and I know that scale is the second argument in the function. Okay, and so it's going to match 1 to scale. And then after it does name by what I'd call exact matching, it then goes again to the order with which it was given to the function. So 3 goes to location, 2 goes to shape. Now I have a third one. And this one is a bit tougher. I have scale again, which we say is 2, but 0 is first, and then L is 3. So I guess the big question, is it going to match 3 to location or 0 to location? So again, pause, think. Okay. So it does, and sorry about my dog again. So it does match, of course, scale to scale, but it matches L to 3, and then 0 goes with shape. So how does that work? Okay. It goes by exact name, partial name, position. Okay. Exact name meaning it says scale equals 3. Partial name was the L equals 3. And then third is by position. So name is probably safe. If you want to make sure you're doing everything right, you want to match by exact name. Okay. Partial name probably shouldn't come into play unless you've accidentally misspelled a word. And then position is if you know the arguments of the function and you're okay with putting them in without the names, then position. One small thing that I want to clarify here is that inside the function I say scale equals 1. Now, if you've done the first assignment already, which you have, I think, hopefully, outside of a function, when you want to assign it a name up in the function call, I have the less than minus sign, which together we call the assignment operator. And I told you it probably more than once, at least in that document, that the assignment operator is the preferred assignment operator in R. Now, the equal sign does work most of the time, but generally, inside a function, inside a function argument, inside the parentheses, you use equals. Everywhere else, you use the assignment operator. And this is a small but intricate argument of setting versus assigning. Inside the function argument, I am setting scale to be 1 or L to be 3. Outside of the function, so setting, you would use an equal. Assigning a value, you use the assignment operator. Okay, setting versus assigning is small and probably pedantic, but it matters to a lot of R people, including myself. So that's what we're going to go with. I guess, long story short, equal sign inside of a function argument, assignment operator, everything else. Okay, now, we also have the ellipsis argument, the ... When the ellipsis argument is in a function call, you either are passing arguments to a function further down in the line of the function, or the function accepts a varying number of arguments. And there are two very different cases, but both happen. You won't have the first one happen, likely, in your tenure in Data Science 1, at least. But you will have the second one happen. So here's an example of number 1. So I have a function that takes in x, y, and then the ellipsis. And then I come down, and inside the function, I say what the function is going to do is it's going to take x, add y, and then add r norm, 1, and then ... We've already encountered r norm. That means I'm adding one random normal variate, but I'm making space here for me to set the mean and standard deviation of the function inside f, because I can't really do that inside r norm, because it's in the inside of the function. So, for instance, if I do f of 1, 2, mean of 100, standard deviation of 5, it doesn't error on me, it works, and I set the mean of 100, standard deviation of 5, meaning a value of 105.66 is very reasonable with that mean and standard deviation. Okay, so that seemed to work. And then the other argument, or the other case in which you're going to see this happen, which is going to happen more often than the other ones, than the first one, is a varying number of arguments. So here's a sum call where I give it 1 through 10, not as a vector, but as actually 10 different arguments. And then I gave it more, 15 through 20, using the colon, which makes a vector of integers from 15 to 20, if you haven't seen that before. And that also seems to work and seems to take the sum of all of them. Okay, so that's the ellipsis argument. Now, scoping. Scoping has to do, it's the last thing we'll talk about, and it has to do with the environment of a function. And this gets people riled up in a bad way when it doesn't work for them, and rightfully so. But we have to understand how scoping works, how the environment works, in order to not get so mad at R. So scoping defines the range of functionality for a variable, and the kind of scoping that R uses is called lexical scoping. Okay, yeah, you should understand it to make your R experience more enjoyable and not so angry. And so what I want you to do is think through this code and try to predict the output. Okay, so x is assigned the value of 5, x is assigned the value of a function, and then f is a function. Oh, I'm sorry. There we go. Now, make like you didn't see the last second of that video and try to predict what the output of f is going to be. Okay? Ready, set, go. Okay, so the answer is 1. Now, how did we get to 1? How did we get to 1? So we called the function f, which is the third line, okay, f of 2. Now, this is just really is a bad use of variables, but it will somehow work. Okay, so this is a bad. I should just use better variables here. So I call the function f and I give it the value of 2. So inside of f, there's one argument, x. Okay, and what f is going to do is take the function x. So it's going to look for another function and then evaluate that function at 2. Okay. Then the question is, which one is it? It's not x squared because I redefined the function x as the fourth line, which also has an argument x and x. Oh, okay. So again, lots going on here. And how does it work? So this is lexical scoping, sort of, hopefully in a better way, or a more understandable way, or another real world example. So R has a systematic set of rules for looking up the value of variables that have to be defined. The problem is I want to find my keys. And so how would it find your keys? How would you find your keys in a systematic way? Okay. Well, first you would check the room that you're currently in. Then you would check the room that you were in last. Yesterday's pants, pockets, living room table, dining room table. Check the kitchen. Check the bathroom. Then you give up. And you just stay home, which is what we all want to do when we can't find our keys. Okay? So R's rules is first you're going to look inside the function where you were called, where you were defined. Or sorry, look inside the function where you're sort of at. Then look inside the function where the function was defined. Then you're going to look where the function was called. And then you're going to keep on going up the ladder until you hit the top. So, as an example, okay, if I run this function, I have a function, f of x, x plus y. I call function of 2, I get an error. Okay, and the answer, well, the reason why is it says object y not found, which makes sense because I haven't defined y. Inside of f, or inside of fun, I'm looking for y. I haven't found it. Okay, I say y is now 5, not inside of the function, but outside of the function. And I run fun again, and lo and behold, it gives me 7. First, it looked inside of that function, and it couldn't find it. Then it looked where the function was defined, which is in the global environment, and that's the same place that I defined y. Okay, now, I have an example here. Sort of, I think is fun, hopefully fun, is a little bit dangerous. Okay, R relies on scoping for everything. That means even the plus sign can be scoped / redefined. Okay, so here I redefine plus. Okay, you try 1 plus 2, you get that. Now, you run the sum function of 1 and 2, and that will actually work. Let's go back, sorry. Here, if you run sum of 1 and 2, that will actually work. Why? Well, sum doesn't use the plus argument inside, so it's not going to just use plus again and again and again. It's special, and so it's not affected by that plus. Okay. Now, here's a more insidious example that I will actually let you try to figure out what I'm doing. Okay. And see if that makes sense. Even if it doesn't make sense, it's just a fun example at the end. Okay. So hopefully that will make it at some point in your R experience a little more fun to work with and a little less frustrating. Okay, so that's scoping, and that's the end of this video.